So today we begin our lessons on perimeter area. This is going to take us into our volume and three-dimensional and modeling unit. So we are going to kind of do a quick review on some basic formulas, how we use them, and what they look like as we're solving a problem. So just some basic review formulas here. We need to find the area of a parallelogram. Keep in mind a parallelogram, this formula is going to work for things like rectangles, squares, and rhombi, plural for rhombus, okay? So our formula here is just area is equal to base times height. Big thing you want to remember, just like we have in the picture, that has to be measured with a perpendicular line. So I can see in this picture here with our parallelogram, the height is not this diagonal side. We're not using that. It's not perpendicular. The height is actually the perpendicular line going from a vertex to the opposite side. It doesn't have to go from a vertex, but in that picture it does. Area of a triangle. Area of a triangle is 1/2 times base times height. A different way that you could look at this formula, same formula, just different form. Base times height divided by 2. Again, the height has to be with a perpendicular line. That is very important anytime that you are measuring height. So here I can see that perpendicular line, that's where the height's located. Area of a trapezoid. Now this is the only one that is not on your formula sheet or not on the reference sheet, so keep this in mind. It's not on reference sheet. Okay. Area of a trapezoid, see is going to be 1/2 the height times base 1 plus base 2. Okay, and there's multiple ways that we can do it, but that's the basic formula. If we have all that information and you have it memorized, that's a way that you could find the area of a trapezoid. Orders of operations, keep in mind you'd probably want to add your bases first, get a number, and then multiply through. Area of a circle. We have pi times your radius squared. And the circumference is basically your perimeter of the circle. It's the measurement, the value of the outside of the circle. Again, two ways that we could write this. Either pi times diameter, or you could have 2 pi r, because 2 radii would equal 1 diameter. So different ways we can look at that formula. Okay. How do these work? So we're going to find the area of the following figures. So here we have a parallelogram. I always like to write my formula down first. The more I write it, the more I remember it. And then it's just easier for me to think, what am I going to plug in? All right, so like we said from the top, the base and the height always have to have that height measured with a perpendicular line. So I'm looking at our numbers of 54 and 71. 54 is my perpendicular line, and it's measured to that base of 71. So 71 times 54, and when we plug that in our calculators, we get 3,834. Watch your label. Your label should be meters squared, or whatever units that you are in squared. That's your final answer. Okay. For letter B, again, write your formula down first. I like to write down the 1/2 base times height. You have that other form that you could write as well. Keep in mind your base and your height. Height's with your perpendicular line. So here's our height of 6. The base is the actual length of the base of the triangle, which is this one. So notice your height's on the outside. That's okay. That happens sometimes. That'll happen when your triangle is an oblique triangle. So we have here 1/2 times your base of 10 times your height of 6. So if we multiply this out, 10 times 6 is 60. If I take half of 60, we get 30. And our label is feet squared. So that's our area for our triangle. Okay. Number 2, we're going to work with the circle. The diameter of a circle we have is 20 centimeters, and we have to find the circumference and the area. So keep in mind they've given you the diameter. Okay, so if we're going to find the circumference, we know the circumference is pi times diameter. So not too bad. We can just plug this one in. So we would have pi times 20, or typically you would see this written kind of just more of a standard notation as 20 pi. Now, if I stop here and I put a label on because circumference is your perimeter, I could say my circumference is 20 pi. This would be what's called exact. That's your exact circumference. There's no rounding. With pi being an irrational number, there's always going to be rounding involved if you plug it in your calculator. So if they said we could do an approximate, or maybe they're going to tell you round to the nearest tenth, well, then you would type 20 times pi in your calculator and get 62.8 centimeters. Okay, so the only difference here is because we had to round, this is now considered approximate. Okay, and if we move on to the area, so area, our formula we have is pi times radius squared. So keep in mind they gave us the diameter. The diameter is 20. To get our radius is half of the diameter, so your radius is 10. So we'll plug this in, so we have pi times 10 squared. And if we wanted that exact area, we would square 10, so 10 squared is 100, and just attach the pi. So 100 pi, and area label would be centimeters squared. Ooh, and I have, yep, okay. Area is pi, 100 pi centimeters squared. This is going to, again, be an exact area. Or it could also be told, leave it in terms of pi. Those are two ways you could express it. Now, if we wanted an approximate one, maybe we round to the nearest hundredth on this, 2 decimal places. Then we could say it's about 314.15 centimeters squared. Again, this is approximate because we are rounding. Anytime you press that pi button, you're going to have some sort of an approximate value. You're going to have to round the answer. Okay, so on the back, we are going to find the perimeter and the area of the polygon. So finding this exact value of the perimeter, perimeter is adding up all the outside edges. So some of this is pretty easy. I can take, here's a side of 1, I count that, that's 1. If I count this bottom side, I see 1, 2, 3, 4, so I have a length here of 4. What becomes a little bit more challenging is this length. But we can find that length by doing our Pythagorean theorem. So I see that's a length of 2, that's a length of 2. And if we did the Pythagorean theorem, I could say 2 squared plus 2 squared equals x squared. So if I add those up, 2 squared is 4. So 4 plus 4, I have 8 is equaling x squared. And if I were to solve for x, I could tell you x is going to be the square root of 8. Now, we could get this because it's saying exact value. I would need to leave this in terms of the square root. I do not want to round. I could simplify the square root. Square root of 8 is really like saying the square root of 4 times the square root of 2. Right? 4 times 2 is 8. But the square root of 4 simplifies down. Square root of 4 I know is 2. So 2 square roots of 2 is also an exact answer. It's just a simplified form. They'll call that simplest radical form. So the nice thing about this is I can see this other side over here is also that same length because it's also formed by a triangle that's 2 by 2. So when we're finding the perimeter, I want to add up all the sides. So I have 1 plus 4 plus 1. And then we have our two sides that are 2 square roots of 2. So I have one that's 2 square roots of 2, another that's 2 square roots of 2. Okay, so when we add these, so combine those. So 4 plus 1 plus 1, that's going to get us 6. We're going to combine these. And when you add square roots, you are only adding, first off, the number inside the square root has to be the same. As long as they are the same, then you can add the number outside of the square root. So I have 2 square roots of 2 plus 2 square roots of 2 is a total of 4 square roots of 2. And if I had a label here, I'm not told centimeters, inches, so I could just say units. Okay. Now the area of the polygon, well, we're going to take a look at this and kind of break this up into 2 different shapes. So if I'm looking at this, I could draw in a horizontal line, and now I see I have a rectangle, I have a triangle. So I'm going to find the area of the rectangle, which is length times width. So I could do 1 times 4. So that's 4 units squared. And then I'm going to find the area of the triangle. And the triangle is, we know, 1/2 times base times height. So I need 1/2 times a base of 4 times my height with a perpendicular line, which would be a height of 2. So 4 times 2 is 8. Half of 8 is going to give me 4 units squared. And then if I want the total area, I'm going to add that up. So I have 4 and 4, which is going to give me a total of 8 units squared for that whole shape. What if we have a picture down here where it's not so nice and my sides aren't all even and easy to find, and I can count horizontally or vertically? Well, what we can do is enclose this region. This is just one technique. I could put a rectangle around this region. And if I could find the area of the rectangle, which we can, this isn't too bad. If I count this, all of these sides going across, I have a total of 6. And if I count up and down, I have 3. So I could find that area of the rectangle and tell you that that's 3 times 6, which is going to give me a total of 18 units squared. Okay, but I don't want that whole area. I need to remove some things. I need to remove this little triangle number 1, and I need to remove that little triangle number 2, and I need to remove this triangle number 3. So I'm going to find the area of all of those individually. So area of triangle 1, okay, we know it's 1/2 base times height. And if I'm looking at the base and the height, I have a side of 6 and a side of 1. So 1 times 6 is 6, and half of 6 is 3, so I know that that is going to be 3 units squared. I need the area of triangle 2. So again, 1/2 base times height. I can see I have a length of 1 and a length of 2. So 1 times 2 is 2. Half of 2 is 1. So that triangle has an area of 1 unit squared. Area of triangle 3, okay, still same formula, 1/2 base times height. I have a side of 3. I have another side of 5. So 3 times 5 is 15, and half of 15, I have 7.5 units squared. Okay, so where do we go from here? Well, I want the inner triangle. I'm going to call that triangle 4. In order to get that inner triangle 4, I need to take the area of the rectangle, and I need to remove each of those little triangles that I found. So I'm going to subtract out 1, subtract out 2, subtract out 3. So the area of the rectangle is 18. I'm going to remove area of 1, area of 2, area of 3. And when we do that, we're going to get a total area here then of 6.5 units squared. And that's what we have left for the inner triangle. So we found it kind of by an indirect method, by using other things that are a little bit easier to find since the sides are measured with perpendicular lines. Okay, and then lastly, similar kind of a problem. We want to find what's the shaded region. So notice the shaded region is a circle. And inside that circle, we have a rectangle. So if I'm thinking area of the shaded is the area of the circle, but I don't want the whole thing because I need to remove the area of the rectangle. So I'm going to find those individually first. Area of the circle. And we know that our formula here is pi r squared. So we need the radius. Well, if I count this whole thing, going all the way top to bottom, that's my diameter, and I can see that that's 6. So if my diameter equals 6, that means my radius equals 3. So I'd have pi times 3 squared, and that would give me about 9 pi. Again, that's exact. If I rounded, I could tell you it's about 28.27 centimeters squared. So now we need the area of the rectangle. We know that that's base times height, so if I were to count, this is going to be a length of 2. And if I were to count up and down, I have a total of 4 boxes. I have 1, 2, 3, 4 boxes. So my rectangle is base times height, 2 times 4, gets me 8 units squared. So if I take my 2 answers and I plug them into the formula, area of the circle we have is 28.27 minus the area of the rectangle, which is 8, leaves me the area of the shaded region to be about 20.27 units squared. So that's the beginning of our area and volume unit. I hope that this helped. Don't forget to like and subscribe, and have a great day.